Some of the information we have already mentioned, the benefit of JSON file and why sometimes it's a good idea to learn them. Okay. Now, another example, this time I won't be focusing too much on it, but instead, maybe as a slight generalization of the example in the slides. So this time we don't have just one dictionary, right? Instead, we will have a list of dictionaries. Remember, square brackets in Python represent a list. And then in this list, we can have multiple elements, each element being a dictionary. Okay? And every dictionary is corresponding to a record in your data set. Okay? So for example, look at the second bullet point here. The highlighted part, we have square bracket, that's a list. Inside the square brackets, we have two elements. Each element is a dictionary. So we have, this highlighted part is the first dictionary, and we have one more dictionary in this list. Right? And this is a JSON file. I mean, if you have a file with the JSON extension, and then you open it, typically it may look something like this, look like something similar to this format. Right? So for this simple example, it's easily converted to a table. Right? So for each of the records, we have two attributes, two keys, ID and name. So those become two names, two column names for the data set, right? And then for the first row, first record, ID is 001, and name is Jack, so that's just your first data record. And that's exactly the content of the first dictionary. Same thing for second dictionary, as the second element, ID is 002, name is Jill, so that's the table format of the same content as what we have in the JSON format. Okay, questions? Of course, if we only have one element, then we don't really need a pair of square brackets, right? So just one element, one dictionary, and that's just a table with one row. Anyways, you may or may not have square brackets, but typically if you have multiple records, you will see square brackets because that represents a list. Now, let's look at one example. So there's a JSON file I want to show you, listing.json. The idea is that let's pretend we have some Airbnb listing data. So if you click on it, once again, it's actually in my GitHub repository. But it's actually a file, right? So you can see it's actually a list of dictionaries. Each dictionary is a record for, let's say, one Airbnb listing. And inside every record, we have ID of the listing, location of the listing, like city, neighborhood, and type of the property. Is it apartment? Is it a loft unit, or is it a house or something? How many bedrooms, price you have to pay per night if you want to stay there, right? And what is the review score on the platform, and what is the information about the host. And again, we have a nested structure. For every host, we can imagine that there are multiple attributes about that host. Right? The host should have an ID, and we should know the name of the host, right? And information like, sometimes we know for Airbnb, some people are called superhosts because they have higher ratings, and they also provided a lot of hosting services to existing customers already. Right? So this is a JSON file. Actually, what I'm showing you is the content of JSON file, but then if you download this file, it's going to be a file with JSON format. Right? And you can open JSON file with any text editor, or even using the browser to view its content. Okay, so questions? Now, what we are most interested in is, again, how to load the data, right? That's the starting point. If we don't load data into pandas, there's pretty much nothing we can do, right? So this time we're going to, again, use pandas to load JSON file and convert it into a data frame. And let's see how we can do that. Okay. So, of course, this first step, so what is the first step? First step is to import pandas so that we can use the library, right? Import pandas as PD. And then we need to provide the location information of this file. So let's first just look at this remote JSON file. Let me right-click and copy the link for this JSON file in my GitHub, right? So let's define a file URL. If you are dealing a remote file, this is often convenient. Okay, so what are we doing here? So after imported pandas, we'll define file URL, which is a string containing the location of the remote file. Okay, and then we can do df, the data frame we want to create, df equal to pd.read. Previously, we were dealing with CSV files. So we did pd.read CSV, but now what we're going to do is to do pd read JSON and then file URL. After that, we can use df.head to show the first few rows of the data set. Right? I mean, here I'm using a remote URL because it's in my GitHub repository. But if you have a local file, let's say it's under disk C and folder documents, and the name is listing.json, you can just use a string like C, C/documents/listing.json. I mean, pretty much the same idea. Okay, so let's try to run it and see what we can get. So we have the data showing up here. Everything looks, I guess, somehow nice, right? It's just a data table. As we already mentioned, every dictionary can be converted into a row in your data table, which is nothing too surprising. However, if you look at the host column, and this is where sometimes things may not be ideal, right? Because of the nested structure, for the key host, the value is another dictionary, right? Of course, we have all the required information already. Like host, first host, we have a bunch of information for the host, like ID and host name. Alice Chen is the host name. Is that person a superhost, true or false? Right? I mean, nothing is wrong here. And we did get all the required information, but it's not as convenient because we have this nested structure, right? A lot of the information still need to be digged out before you can do some meaningful operations on it. Right? So that's a good operation by using pd.read JSON. But if you have a nested structure, things may not be extremely desirable if you simply use only this function. Okay, so what do? As mentioned, we are going to find out a way to flatten the nested structure so we can convert it into a normal table. So what do you think the normal table, without a nested structure should look like? So what do you think? I mean, if you are asked to design the table to convert the last column host into something that is more flat, how will your table look like? Right, for host, we have several pieces of information. One idea maybe for each host, it's one column, but how about we expand that column into several columns? Here we have 3 key value pairs in the dictionary that represents the information of a host. So how about we break down the host column into 3 columns, right? First column is the ID of the host. Second column is the name of the host. Third column is whether or not the host is a superhost, right? And then we can flatten things out, right? So even though things are not so intuitive, but the idea is that for every host, again, we have several pieces of information. How about we use a separate column to store each of those 3 additional pieces of information on a particular host, right? So let me know if you require any more detailed explanation. And we're going to exactly implement that idea. Okay? Now let's see how we can do things. Now, Actually, this will be slightly more involved than just using a simple function, but it's not too complicated, actually. So first of all, this time, because we're not directly using a pandas function to convert things into a data frame, so this time we're going to use an approach that takes several steps. Right? So the first step is to somehow get the remote file in GitHub, so that we can do things locally after downloading that JSON file. Right? Of course, here it's not really downloading to our local computer because we're doing things in Colab. It's going to be on the local virtual computer in Colab's server. So, in order to get data from the internet, including GitHub repository, or actually later on we'll see there may be many other situations we need to download data from the internet. So this is what we need to do. We need to import a library called requests. A request simply stands for HTTP request or internet requests. Okay, so let's import that file, library, sorry. And once we have imported that library, next, what we can do, I have created some comments there. So if you want to let Gemini do things, I think it can already work out many things based on the comments. But let's actually write down the detailed command so that we can understand things. Okay. So now we're going to make use of this request library. Okay. So the way we can do it is that we're going to do requests. That's the library. And inside the library, there's also a function called get function. Right? Actually, it's very intuitive. The get function just allows you to get data from the remote server. Right? Later on, we're going to see there's another function called post function. And post function is for us to send data to the server, and get function is for us to download data. Okay. So what do we get? We want to get the remote file, the remote JSON file, but we already defined the file URL, which is the long URL that directs to my GitHub repository. Okay, so we're gonna just do file URL, and that already allows us to, get the file. But let's see what we can get. Okay, so let's define a variable. We can call it response. I mean, if you want it to be shorter, you can sometimes call it just R or res, something like that, right? So right now, let's get a file and store it in a variable called response. And what we want to do is to see what will happen. Okay, so let's just type the name of response, the variable we create as a response to the HTTP request of getting data, and then let's run it. Now, the response variable doesn't really show you much information, right? What we have is response 200. So the real information is hidden inside this response variable, but if you only invoke the name, it will only give you this display. But this display is actually already containing some information. But actually, I have the explanation in a different notebook. So right now, we only need to know that if you see that it returns a number, the number 200, it means that request is successful, right? 200 is good. If you get a number that is in the 400 series, 400, 401, 403, 404, it means that something is wrong. You get an error. You didn't successfully get data from the remote server. Right now, things look okay because we've done 200. Right? So remember, 200 means that whatever you requested actually went through. Okay. But what do we have in the response? We don't directly see it, but then we can do response.text, because whatever we get from a file, it's usually textual information, right? This is the content, text content inside that file. So let's see it. So this is actually the textual file. As we can see, it's already something like a JSON file, right? Because we see the square bracket to show a list of dictionaries. We see the curly brackets to represent dictionaries. So basically, the content of the JSON file. However, it's a bit messy, right? You see the /n symbol, which means new line, which is not exactly make it the JSON format. So instead of showing the textual context, let's use another function called response.json. And this time we need the parentheses because it's a function attached to the response object. Right? So let's see what happens. It's basically the same thing, but it gives you the nicer JSON format. Right? It gives you a list of dictionaries. Nothing too different from the textual information, but it's cleaner. Okay? So this is what we want to get. So we fetched the file, remote file, and used the .json function to convert the content into JSON format. Let's store it in a variable called data. Okay? So from that moment on, data, this data variable is going to be something we want to work on. Okay? And it's just a list of dictionaries, right? It's a JSON format data set. So let's run it, and then as we can see, nothing is too different. We just assign the JSON data a name called data as a variable. Okay. Now, from now on, we only need to work on data. But before we move on, let me show you another different approach. So one approach we already have here is that I directly get the data from the GitHub repository, right? So basically, it's a sort of a more direct approach. But sometimes maybe you don't have directly the file available on the remote server. Instead, you have it on your local computer. So let's quickly also see how we can actually load the JSON data from a local file. Okay? Of course, for Colab, we don't really get local files. So what we need to do is that in this Colab editor, look at the left column, click on the file icon, right? So this is something we did last time. And then once you enter the file component of the editor, you can look for the Google Drive icon to load your Google Drive and connect to Google Drive. Usually it just takes a few seconds to load. As you can see, it shows that it's mounting. That's mounted, right? So look at Drive, and there's a subfolder called My Drive. And usually I keep things under 0712, but what you can see really depends on what kind of things you have in your own Google Drive, right? So now this is where I have a copy of the same JSON file. But if you don't have it, you can download from my GitHub repository, and there's a button you can click to upload data. You can upload it to your Google Drive, either directly inside Google Colab, or you can go to your Google Drive web page to upload the data from there. But in any case, I already loaded the file from here, so you can see the listing.json file, and click on the three dots on the right hand side, and let's do copy path. Right, so this is how we can get the address of the file inside the Google Drive. And then let me go back to the coding cell. Okay, so this time let's import another library, which is the JSON library. JSON library is for you to deal with mostly local JSON files, to convert JSON file into meaningful data. Okay, so let's import the JSON library to manipulate the JSON library. I mean, pandas can actually handle JSON file, but here we're not directly using pandas, right? So that's why we need this library. Now, as you can see, we are already having some hints from Gemini, but let's actually type in the details so we can understand things better. Okay, so with open, and then inside this open function, we need to provide, first of all, the location of the file we want to open. Right? So at this time, don't rely on the hint because it's not just a directly listing.json. Instead, let me paste. Right? Remember, I copied the path of the JSON file in my Google Drive inside Colab editor. So this time, I'm just pasting the location of the JSON file in my Google Drive. Okay? And the second argument of this function is R, it's the string R. You can use single quotation marks if you want. They are not much different. So R means that we are reading the file. I mean, sometimes you want to write into the file, but right now we only need the read access. And then with this file opened, and then let's say as F, because we want to give a name of the opened file, right? This is sort of the default syntax for handling files. Right? Now, once you have opened that file and give that file a name, let's call it F here in Python. Now we can extract data outside this file. Extract data from this file. So let's do data equal to JSON. That's the library we imported. Inside the library, there's a function called load. What do we load? We just load the file we just opened, right? So JSON.loadF. And once we have done that, we'll be able to load the JSON content into the data variable. So let's view the data variable content by typing its name in the end of the code cell. Right? Previously, of course, we already have the data variable from the pandas function, not pandas function, actually from the request.get function. This time, it's just going to overwrite the previous data variable, but the content will be the same. Okay, so this is a different scenario where, let's say, you have this file locally on your computer or locally on Colab's virtual environment, and then we load the file, read the file, and load it into the JSON format data variable called data, and we got a bunch of dictionaries. Right, it's the same. Now that's how we load the JSON file into a variable without using pandas. Okay, now next step is that we're going to flatten out the JSON file by removing the nested structure and want to get a flat table instead of a nested structure. Right? So let's see how we can do it. So let's create a variable, and the variable name is called df. Let's call it flat. Now you can call it anything, but let's say it's df flat. Right? And then we're going to use pandas again. pd.json_normalize. Normalize means that we're converting into the normal data frame structure by removing the nested structure. Okay, and then what do we normalize? What's the data variable we have loaded from the JSON file? There's one more thing we can specify, which is a separation symbol. So it's sep equal to some symbol. So right now, it's commonly to use dot, or if you want, you can use underscore or dash, whatever you want to use. Right. So let's see why we need this separation symbol specified here. But by doing this function, what we can do is simply, it's only 3 records, so just let me just type the name of the data frame to see the full content of the data frame, right? So here, we just have the JSON data stored in the variable data, a bunch of dictionaries. Instead of directly loading it, we used JSON normalize. So this means that we are doing some flattening, right? We're removing the nested structure. So let's see how it looks like. Now, not surprisingly, the first few columns are exactly the same, but what's different is that now the host column, which has the nested structure, is expanded into 3 different columns. Host.id, host.name, host.is_superhost, right? So by doing this kind of operation, JSON normalize, what we did is exactly to convert the nested structure into separate columns. Okay? Now, the dot symbol as a separator is exactly the dot between host and ID, host and name, and host and is superhost. Okay? If you want, you can replace it by underscore. And let's run it again. Nothing too different, except now when you are viewing the ID of the host, name of the host, and whether or not it is a superhost, between host and ID, host and name, host and is superhost, we don't have dot anymore. Instead, we have the underscore. Right? So this is exactly something you can specify. You can also use the separation symbol, which is a vertical line, and then run it again, and then you will see that now the master level attribute and the the inner level attribute is not separated by this new symbol. Okay, so that's how we actually can get JSON data and use the JSON normalize function to convert it to a normal dependence data frame.